Hey everybody, so we're going to be working on the warm-up for day 20 of the Algebra 1 notes, and so it says the following. So the inaugural attendance of an annual art festival is 80,000 people. The attendance Y increases by 6% each year. Write an exponential growth function that represents the attendance after t years, and how many people will attend the festival in the 5th year, round to the nearest 1,000. So, thanks to our formula from the exponential functions, we know that, an exponential growth or decay, we know that my initial value was 80,000 people. Because this is increasing, this has to be exponential growth. Now, if I want to express my rate 6 in percentage, I have to take 6 and divide it by 100, which will give me 0.06. So 1 plus my rate, which is 0.06. And then we have to do after t years. So if we simplify this, we're going to get the exponential growth function that they wanted us to find, which is 80,000 times 1.06 to the t power. So there's our first answer. Then they ask us how many people will attend the festival the 5th year that this happens. Well, the first year that this happens, t has to be 0, right? Because if this is 0, this all becomes 1, and 1 times 80,000 is my initial attendance. So t is equal to 0 means year 1, which means that t is equal to 1 means year 2, which means that t is equal to 2 means year 3, and so on and so forth. And so this tells me that t is equal to 4 represents year 5, which is exactly what we are looking for. So we're going to take that t is equal to 4, and we're just going to stick it in this function that we just figured out earlier. So I'm going to do that in a calculator, because you're supposed to do it in a calculator anyways. We're going to do 80,000 times 1.06, and we're going to raise that to the 4th power, because t is equal to 4, and that gives us this number right there. So we can say that y is equal to 100,998.1568, but because they told us to round to the nearest 1,000, I'm going to leave my answer like this. So it's 100,998 people approximately will come by to that festival at year 5. Alright, so that was A, and part B is a little bit more straightforward. We're just looking at this graph here, at this table here, and have to determine whether it represents exponential growth, exponential decay, or neither. So let's see. Our first requirement, as always, is we have to check that our x's are increasing or decreasing, whatever, by the same amount. Right, so then 0 goes to 1, and then 1 goes to 2, and then 2 goes to 3. So this definitely goes up by 1 consistently. And so now what we have to figure out is if I can find some number down here that when I keep multiplying my y values, I find my next one. If I'm able to do that number, if I'm able to find that number, then this means that this table has to be an exponential function. And we notice that every time we go from y value to y value, we're actually cutting our values in half. If we want to express that as a multiplication, we can actually say that 24 times a 1/2 gives me 12. 12 times a 1/2 gives me 6. 6 times a 1/2 gives me 3. And so now we know that because there is a constant change in x, because there is a constant factor being multiplied with my y values, this has to be an exponential growth. And it has to be growth because my y values, decay, because my y values are actually decreasing. So let me just write that down before I mess it up again. So this is exponential decay. And they don't ask us to, but if we really wanted to, we could find an equation like we did up here. Well, I'll do it really quick. We're going to do initial value is 24. That number that keeps being multiplied, that factor multiplied over and over and over, is 1/2, 0.5. And then we're raising that to the t power. So based on the decay form that we already know, we know that this has to be decay because look, this number inside here is less than 1.